Hi everyone. So this is the second video on how to conduct a biomedical experiment. And in this video, we will look at 20 general tips for conducting motion capture and EMG data collection trials. If you guys like this video, don't forget to give me a thumbs up. And as always, do subscribe. Alright, so a quick recap from our previous video. We already looked at the conception of the study, obtaining ethical approval, subject recruitment, and in this video we are going to run through the procedures for data collection, and we will even touch on data storage and labeling towards the end of the video. In the following videos, we will look at data pre-processing, conducting a biomechanical analysis, getting the results, and then actually interpreting those results and drawing some conclusions from it. Now, the content of this video is mainly taken from this paper, which I published along with my research group, the research group I'm part of. And this paper details a motion capture dataset that we collected and published. It looks at the methodologies and the procedures we went through to collect the data, and also the steps we took to validate and verify the accuracy of the data we collected. So I'll leave a link to this paper in the description down below. It's also available online and it's open access, so anyone can view it. If you all are interested, please do go ahead and read the paper. And if you all draw from it, do cite or reference the paper as well. And with that, let's get into the 20 general tips. All right, tip number 1, laboratory setup. So this is a snapshot of my laboratory at Monash University in Malaysia. And you would actually have to decide how you would set up your laboratory, how you would utilize the space that's provided to you, how you would allocate the equipment, and where you would place them. You would also have to decide on what equipment you're going to use. That's what equipment that's already available and what equipment you need to purchase. And even things like consumables, surgical tape, alcohol swabs, or even motion capture markers. You should also utilize the space such that the participant feels comfortable, is not claustrophobic, and has enough space to walk around and move around and perform the experiment. You should keep your workstation in a suitable location such that you can monitor all your equipment and your readings while observing your participant and engaging with them and talking to them to make sure they feel comfortable and they know what they're doing throughout the experiment. Tip number 2, motion capture cameras and the capture volume. So in our laboratory, we actually have two types of cameras. We have the Qualisys, which is a slightly older system, and we have an OptiTrack motion capture system as well, which is newer. But in the paper, we use the Qualisys motion capture cameras. Now, with regards to capture volume, there is a general rule of thumb that you can follow, and that's that if you are analyzing or capturing, I would say, large-scale motions, things like walking, running, jumping, squatting, then use a large capture volume. Whereas if you're analyzing more detailed or intricate movements, then use a smaller capture volume. As an example, in our study, we analyzed the lower limb and we looked at the subject just moving or walking up and down. So we actually wanted a large capture volume. And that's why the cameras are ceiling mounted and sort of angled or targeted towards this region surrounding the 3 force plates, which is our capture volume. On the other hand, if you were analyzing things like finger motion, you could actually bring these cameras down, mount them on tripods, and then focus them into the region that you want to capture, and only that region. Another thing you would also need to consider is calibrating your motion capture system with respect to your capture volume. So our capture volume was actually just these 3 force plates, but we calibrated our motion capture system around the 3 force plates, so that it encompasses our entire capture volume and it encompasses that entire region. Right. Tip number 3, maintain a smooth and flat walking surface for your subject. Whether you use wooden planks like what we did or have your force plates embedded into the floor of your lab, ensure that the movement area is smooth and flat to minimize tripping hazards and to ensure the subject doesn't have to step up a little bit every time they meet a force plate. Number 4, synchronization. It is an absolute must to start synchronize all your equipment so that they start at the exact same point in time. End synchronization is not always necessary depending on your experiment, but start synchronization is an absolute must. So in our experiment, all three force plates, the motion capture system, and the EMG and IMU systems were all start synchronized. And we did this through a synchronization box. You can use a synchronization box if it comes with your motion capture equipment. You can also connect all these devices to maybe a microcontroller and use a start button or a start switch, or you can supply even a 5-volt pulse to trigger each piece of equipment individually, but at the same time. Yes, there will be minor delays of maybe a couple 100 milliseconds, but these are acceptable delays. Right, tip 5, which is the final tip for this picture, and that is setting the global origin. So we set our global origin at this point, which is the corner of force plate 1. And you can actually do this on the motion capture system software once your force plates are integrated with your mocap system. And it looks like this. So our 3 force plates, and this is our global origin. Make sure every trial has the same consistent global origin, and define your axes X, Y, and Z, X being anterior-posterior, Y being medial-lateral, and Z being the vertical axis. But these definitions may change based on your motion capture system. Tip number 6, motion capture markers. So there are a bunch of marker sets, predefined marker sets that you can use. You can check the Visual 3D Wiki by C-Motion. You can check a bunch of research papers, or you can even look at your motion capture system software, which may offer predefined marker sets depending on the part of body you are analyzing. So as an example, this is our lower body marker set, and we had 2 types of markers. We had segment definition markers and tracking markers. Now, tracking markers are what you place on the body segments to track the motion, such as this cluster over here on the thigh and this cluster over here on the shank. Segment definition markers are what we use to recreate the skeletal structure of the body during the biomechanical analysis, and these are placed at specific anatomical landmarks. So for example, the markers on the ankle, the knees, and the hip are all segment definition markers. Right, and tip number 7 is to do with the marker naming or labeling convention. We give a unique name to each marker, of course, to identify that marker and track that marker throughout the motion capture trial. The name or the label depends on the anatomical point at which the marker is placed. So something like RTH1 just stands for right thigh 1, while RSK1 would stand for right shank 1. But the segment definition markers depend on the bone segment at which that marker is placed. So RASIS stands for right anterior superior iliac spine, which is that particular bone segment. So in this manner, you can name or label each marker in your motion capture set. And tip number 8 looks at the use of surgical tape and Velcro bands. So the tracking markers, that's the ones over here, don't have to be all that accurate, and they don't have to be symmetric, because they're just used to track the motion of that particular segment. So you can just slap them on with Velcro bands or just fix them to the body in whichever way you want. But the segment definition markers, like the ones at the knees, the ankles, or even ones at the toes, have to be placed at that exact bone segment or anatomical point. So I prefer to use surgical tape because it gives me a lot more control over where I place the marker and its orientation. And with tip number 9, we move on to surface electromyography, or SEMG. So the standardization body for EMG is cenium.org, which stands for Surface Electromyography for the Non-Invasive Assessment of Muscles. And if you visit their website, they will actually give you a ton of information on how to perform surface electromyography, what muscles you can target, how to place the electrodes for those particular muscles, how to find those muscles through palpation, how to perform the relevant MVCs or maximum voluntary contractions, and a bunch of other general information. Right, and in tip number 10, we have the placement of EMG sensors on the body. So this is the muscle that we're targeting, the rectus femoris, which is one of the more prominent muscles in the quadriceps. And the first thing you need to do is actually clean the area. So if you have hair on your subject, you may need to shave it off, but this is not always necessary. Else you can just clean the area using an alcohol swab. So once the area is cleaned, you need to find the most prominent bulge of the muscle. And to do that, I'm actually asking the subject to tense their leg and then to flex it up and down And what I do is I just feel with my finger, that's palpation, until I can find the most prominent bulge of the muscle. And once I found it, I place the sensor at that point. So these are DELSYS, EMG, and IMU sensors. And behind each sensor is surgical grade double-sided tape, so it sticks to the person's body. But I put a piece of surgical tape on top as well to ensure that the sensor doesn't come loose when the subject is walking or moving around. And in tip number 11 is the use of these black Velcro bands which were placed around the EMG and IMU sensors. So while conducting our trials, what we realized was that the EMG and IMU sensors tended to give weird or weak sensor readings as they became dislodged or loose even with the use of surgical tape. And this was because of sweat and the subject moving around in general. So to ensure that these sensors were pressed firmly against the skin and did not come loose or did not slip, we used these black Velcro bands and wrapped all the sensors within them. Number 12 is collecting the maximum voluntary contraction, or MVC, for the EMG signals. Now, in the MVC, we ask subjects to maximally contract or tense a certain muscle group to collect a maximal baseline or benchmark. And all the other EMG readings can actually be normalized against this benchmark so that they can be obtained as a percentage of the maximum. Traditionally, it's a good practice to collect the MVC before you start motion capture trials so that the subject is not tired. Now, in this case, we are collecting the MVC for the tibialis anterior, which is this muscle over here, by asking subjects to maximally contract their ankle, which is dorsiflexion. And in this one, we are asking them to tiptoe as hard as possible to collect the MVC for this muscle over here at the back, which is the gastrocnemius. And one final tip, that's tip number 13 before we start data collection trials, and that is to ensure all your subjects are wearing tight-fitting clothing or sports attire. And this is very important to prevent loose clothing from getting entangled while the person is moving, or to prevent it from covering any motion capture markers so that you can get a clean motion capture trial. Right. So number 14 is to let your subjects start moving a little bit behind the capture volume so that by the time they reach the capture volume, they would have reached their normal walking velocity and pattern, unless of course you are analyzing the start of the motion. With this, you should also start your recording, wait for a few seconds, and then instruct your subject to start moving so that your equipment has some time to normalize. Tip number 15 is if you are using force plates, you must instruct your subjects to keep one foot on each plate. If a subject places their foot on the crossing between two plates, then their ground reaction force will be picked up by both plates, which will give an incorrect reading. So when walking, subjects should keep one foot on exactly one plate. Right, tip number 16, which is the final tip for data collection trials, is to collect both static and dynamic motion capture trials. So this is a static trial where the subject just stands still for about 5 to 10 seconds with a T pose, that means their arms in a T position or crossed over their chest. And the purpose of the static trial is to get the marker position so that you can recreate the skeletal structure of the subject during the biomechanical analysis. Dynamic trials are the movement trials where the subject performs motion. So if you change the marker positions or adjust the markers during the dynamic trials, you should always retake a static trial to ensure you have the new marker positions captured. Right, and that brings us to number 17, which is to do with data storage and labeling. So after every trial, make sure you store your data properly, make sure you back your data up because it's very easy to make a mistake and lose your data. When storing your data, you should store it in a de-identified manner and be methodical and organized in how you store it. So for example, use a consistent naming convention when you store and label and name your files. So for example, I use a convention like this: S01 for subject 1, for subject 2, 3, and so on and so forth. Each folder follows the same pattern. I have motion capture, EMG, and IMU, and this is a qualitative survey. So motion capture has my static file and my dynamic trials. On the EMG and IMU, I have the EMG and IMU files together as a CSV and the MVCs for each muscle group. Tip number 18 is to do with validating the data that you have collected. So for the motion capture data, you can validate it very easily by plotting out the joint angles and comparing that with literature. So you can do something like this. You can plot out the joint angles for the different joints, hip, knee, and ankle, for example, and then compare this with existing plots in literature for that particular motion. You can compare the plots visually, or if you want to be more specific, you can consider the numbers and perform a statistical test like an interclass correlation coefficient, an ICC, or even look at confidence intervals to justify that your data matches the overall trend in literature. Number 19 is validating EMG data instead of the motion capture data. So you can use the same method. You can obtain your EMG readings and then compare that with values in literature for the same motion and the same type of muscles. Or you can even do it with the MVCs. So that's what we did in our study. We had our muscles and we obtained our MVC readings and compared those with MVC values from literature, and we found a correlation to show how closely they match each other. The higher the correlation, the better the match, which justifies the validity of your data. Right. Number 20, the final tip, is to collect as much details as possible about your subjects. These include things like age, height, weight, sex, location, addresses, phone numbers, ethnicity, and even things maybe about their lifestyle, health, or their habits through questionnaires, surveys, things like that. And the purpose of this is that you can build up a lovely database about how your subjects operate and how they live and about their lifestyles. And that information may be useful down the line when you want to draw certain conclusions or analyze data in a certain perspective. Alright guys, so that's the end of this video. 20 tips for motion capture and EMG data collection. And in the next video, we'll have a look at data pre-processing. Now, if you guys like these videos, don't forget to give me a thumbs up and to subscribe. Thanks for watching, and I'll see you all in the next video.